10 ohm resistors, breadboard jumper wire, I'll use an Arduino Uno as my voltage source, LEDs, a breadboard, 7408 IC, a schematic of the 7408 IC. There is quadruple 2-input positive AND gate. Here is a logic symbol for the AND gate. The AND gate can have 2 or more inputs but only one output, making it a bistable device. Bistable means that the output could only exist in 2 discrete states of either high or low, on or off. The output C is dependent on the 2 input A and B. Since there is only one output, that output could only exist in 2 states, which is high or low. We will examine how that state changed with respect to the 2 input A and B. The truth table shows the 2 input. Since there are 2 input, the AND gate can have 4 possible combinations of these 2 input. That is, both could be off, both could be on, or one could be on and the other could be off. Mathematically, we can obtain these possibilities from the equation 2 to the n, where n is the number of input. So 2 to the 2 would give us 4. 4 possible combination from these input, which is 0, 1, 2, and 3. 0 could represent in binary as 0, 0, 1 as 0, 1, 2 as 1, 0, and 3 as 1, 1. We will obtain the output from the circuit. This is the schematic of the circuit I will be building. The Arduino is used as a voltage source, where the ground pin is sent to pin 7 of the IC, and 5 volt is sent to pin 14, which is VCC. Pin 3 would be sent to the output LED. Pin 1 and pin 2 are the input. The yellow jumper is used as input A and the green wire as input B. These 2 wires would also act as a switch between VCC and ground. Here I have the completed circuit. Input A and input B, the yellow wire and the green wire. So they're both 0, 0 grounded. I'll send the yellow wire to VCC, so that would make it 1, 0. At 1, 0, the output is still low, which is 0. At 0, 1, the output is still low. At 1, 1, the output is high. From the completed circuit, we could have seen that for an input of 0, 0, the output would have been 0. For 0, 1, the output would have been 0. For 1, 0, the output would have been 0. And for 1, 1, the output would have been 1. Thus, the only time you would have an output of high or 1, the input or both input must be high. Thus, C is equal to A and B. That's why we call it an AND gate, because both input must be high. A and B must be high.